Hello guys, welcome to another series, another lecture of Kleppner series. My name is Saddam Leonardo Cap. If you haven't seen my previous video, please go back and see it. What I'm going to today, we are actually talking about vectors. From the previous version of this topic, we have talked about a few things vector, why vector is important. Today in our camera, we have the feature of artificial intelligence, and by seeing it, by observing your face, it can tell you the age. Or maybe if you have little bit advanced phone, because we have today, if you show some object, it can give you that it is a book, it is a car, it is a house or something and so on. So how is it possible? Because whatever it is seeing, it actually translates everything in numbers. And when you show those objects, they have the set of data, they are going to compare with those numbers, and if they matches, they are going to say that okay, this and this has some dimensions, and because of these dimensions I can say that this belongs to your age group like 2026, maybe it belongs to a book, maybe it belongs to some data. So artificial intelligence, this thing actually works on these features like vectors. So for today's part, we will introduce that okay, we have to be specific. We don't care about what is the algebra in a very abstract form. Let's just constrain ourselves with Eulerian coordinate. Means we are going to talk about in this video Euler system with having x, y and z, because as we understand it, we are living in three-dimensional universe. Well, Einstein has wronged us. Okay, Einstein has told us that we are actually living in four-dimensional, but let's talk about one space, not I am going to include anything like time. And we want to understand that how this algebra actually going to take place if I am introducing this Euler coordinate system. What was the algebra? Algebra was like two vector I am adding, two vector I am cross product or having the dot product. So what kind of changes will take place? Now if I am multiplying some vector with some constant or some real number, what is going to happen if I am having this Eulerian system? So this is more or less we are going to talk about. Before starting this, I am going to tell you about what we are going to achieve in this video. First of all, I am going to talk about what is the component of vector. For an example, if you have a vector in certain space, how you going to understand what is the component of vector, and then we will understand that what is called base vectors. We are going to introduce position vector and displacement, because since we are working in physics and there are three quantities that is important, which is one is called position vector, another is velocity, and third one is acceleration. So we will understand both things in one-dimensional, two-dimensional and three-dimensional, how these quantities are actually coupled with vector and how they are going to define in mathematical framework. So this is our job more or less. Components of vector. First of all, I'm going to read this thing. The fact that we have discussed vectors without introducing a particular coordinate system shows why vectors are so useful, as we have done in my previous video. Vector operations are defined independently of any particular coordinate system. However, eventually we have to translate our results from the abstract to concrete. And at a point, we have to choose a particular coordinate system in which we are going to work. The combination of algebra and geometry is called analytical geometry. Means that when we are trying to do algebra and in some geometric manner, because we are introducing the coordinate system which is a geometrical object. It has the length, like you are having the brick or home, these are geometrical objects. Analytical geometry has consistent procedure for describing geometrical objects by a set of numbers. So if you are in a room or in a places where you can go back and forth, forward and backwards, up and down, we can all thing translate into mathematical forms like in numbers. So this is the greatest thing about analytical geometry, that we are actually translating each and object with some numbers. You know what is the important thing about this thing, the analytical geometry? Artificial intelligence. Basically, artificial intelligence, let me take you a very brief example, like us, human being. We have the face, okay? We are fat or thin, and we have also height, we have age. As we are growing up, our face, our structure of the body and everything is actually changing. So our whole structure is changing, and whole structure can be translated, can be mapped into some numbers. Okay, in Eulerian system we are having some height and so on, we are having this thing, this feature, For an example, if you are in some intelligence guy, like government have some data like fingerprints, eye prints, everything is actually translated into some specific numbers. Today in our camera, we have the feature of artificial intelligence, and by seeing it, by observing your face, it can tell you the age. So vectors are nothing but set of numbers in mathematical language. But we are in physics, so for us, these numbers have some meaning, like distance. Had dimension, we are calling it length. Okay, like velocity. Velocity represents that how your distance or how an object is actually moving in particular time frame. Or how, if we are defining some acceleration, then how an object velocity is actually changing in particular time frame. So we have very interesting feature to understand the dynamics of something in particular mathematical language. We call it length, velocity, or displacement, velocity, and acceleration. If you can figure out these three features like acceleration, velocity, and distances, you can define any dynamics of the system. But to understand these quantities, we need to introduce coordinate system. I have this 2D interface, like I have a space of x and y, and there is some kind of abstract vector like this one. Maybe it has some direction and so on. So whenever you are working with some abstract vector means that its orientation is neither in x and neither in y. Okay, neither in z specifically. Okay, this vector has some orientation, maybe some angle. Okay, some angle which is making with axis x. So we want to understand that how can we understand the information about this vector. So to understand this vector, we have to first decompose this vector into particular components. We call it components in x direction and some components in y direction. So x component we are going to denote with ax, and y component we are going to denote in ay. So what we are going to do is that you are seeing here this object nicely. So we are making some perpendicular guy here, and we say because from this to this vector has length, or this vector is denoted by a vector. What we are going to do, let me just, because we want to find this ax is parallel to, this is parallel to x-axis, the component which is parallel to its x-axis, and the component means that it has what is the magnitude of this vector in x-axis. That is the meaning of component. So if I am going to introduce cos of theta, I think you know this is your base, maybe this is base A, base B, and we have this vector A. So B is, now since we are actually working in the magnitude, so therefore we have to define this, what is the magnitude of A vector. So B is A vector cos theta, and now since B is actually parallel to x-axis, we are having this AX. So AX is the magnitude of this vector, and what is the direction in x-axis. Similarly, if we try to find parallel to y-axis, we can simply say sin theta is, now parallel to y-axis, let's say we are calling it P, therefore P by hypotenuse, that is A vector and magnitude. Therefore this B is, now simply we are calling it P is equal to A sin theta. Okay, and this is your AY. So whenever we are working with vector, one thing we are going to do is that whenever we write this vector, A vector, we are going to write it in components, like what is the component in x direction with x, the x hat is actually giving you the direction, and AX is a component, this is a scalar quantity, or we are calling it magnitude, and similarly AY and y hat. Okay, so we know in 2 dimension, I have already break down that this will be have some the magnitude of that vector, and cos theta x hat plus magnitude of that vector sin theta y hat. So this is the simple understanding of vector in 2 dimension. So you see, we had, first of all, in the previous video, the vector was the simple vector. But now when we are constrained that, okay, I am particularly interested in Cartesian coordinate system in which we are living in. So tell me, if I am having some kind of vector, how we are going to I'm going to actually extract how we are going to extract information from vectors. So if you have vector in three-dimensional space, we have to break down in these components. Now this is a 2D system. Now in 3D system, what we are going to introduce that if you have some vector, it will have ax x hat, ay y hat, these guys, and az. Therefore, we will have something ax is a cos theta, ay is a sin theta, and maybe az will having something, or maybe simply az. Okay, so this is the interesting feature of vector in 2D and 3D system. Now we will understand that can we give you the resultant vector. Resultant vector is nothing but it's a resultant, the magnitude of this thing. So magnitude can be taken down as ax square plus ay square plus az square, or in 2 dimension it's simply ax square plus ay square. Now if you do it using equation 1, which is your 2-dimensional thing, so it will give you nothing but vector a square cos square theta plus magnitude of a vector square sin square theta. Okay, therefore now a square, and this is the same guy, therefore I can simply write that what is the whatever the magnitude of this thing will be just outside of square root and sin square theta. Now we know what is this thing, it will give you 1, so square root of 1 is 1. So therefore magnitude of this vector is nothing but this one. So it will be something like maybe 5, maybe 6, and maybe 7. So this is the way we are understanding the components of any vector. This is important to understand. It is a very important result. One thing, how can we understand the orientation of any vector? To find the orientation of vector, so how can we find this angle theta? So we know we have this ax is magnitude of a cos theta. Now ay is magnitude of a sin theta. To find this, we just simply divide this from this one. So a sin theta over a cos theta is nothing but ay over ax. Now these guys are the same, therefore they are cancelled. So sin theta over cos theta will give you tan theta, which is nothing but ay over ax. So tan theta is going to describe you the orientation of some vector if you know the components of this vector in Cartesian coordinate system, not in some abstract space. So this is more important. Now when you will, where it is important in physics, when you will solve kinematics problem or force problem, they will give you that okay, some object is moving or there is a force applying in this direction. Now tell us what is the displacement in x direction. So if force is applying this way and this object will move this side, but they will ask that what is the displacement in x direction. Then we have to find what is the component in x direction, what is the force component in fx direction. Now they are asking actually about x-axis, so you have to understand what is your fx, not fy. And then we have to find what is the displacement or what is the work done by this object due to this force. So these are the very much simple problems, but there are again so many complicated problems, like if your object is in electric field, if your object is in magnetic field, and these electric fields and magnetic fields are in arbitrary direction, then find the torque, find the force, okay, what is the acceleration for these charged particles. These are the very interesting stuff can be done. If you understand vector, then you can do, otherwise you cannot. So if you are in 12 also, you have to understand very amazingly that what is vector. So vector for physicist, to become a very good physicist, you have to understand vector. You have to be concrete in this thing. Okay, we can add two vectors. So I know that if you have vector and you are working in coordinate system, so we have three components, ax, ay and az. Similarly, two vectors are there, so we will have some coordinate like bx, by and bz. So when we are actually adding these vectors, so what happens is that only this component will add. So ax plus bx in x direction, ay plus by in y direction, and az plus bz in z direction. You cannot add ax plus ay or bx plus by, or we cannot add just ax plus by. You have to be specific that which vectors are parallel. for that addition also you have to break this component in x-axis, y-axis and z-axis. That's why these are important. So when you are in 12, nobody will tell you that why we actually break these components, break the vectors in components. But here you will get the great idea that why we don't actually specifically work in abstract thing, but we are actually breaking any vector in some components. This is the reason, because we want to understand everything in particular coordinate system. So if we cannot specify any particular coordinate system, then we cannot understand the physics of anything which is happening. Okay, now we have this multiplication also. So first of all, I am going to introduce you multiplication of dot product. I hope you understand, but this is simple rephrasing things. This is simple that let's make this thing more abstract and more understandable in the view of that how a scientist or how a particular person who is more advanced in physics think about something in vectors. That is the meaning of advanced study in physics. Dot product is particularly if we have this a dot b and a and b are defining by this guy, how we are going to dot it. So dot product is actually have some particular rule that if you have two vectors in parallel, then it will give you result. Otherwise, if you are working with some perpendicular or orthogonal vector like y hat, z hat or x hat, z hat, so these guys like x, y or z, these are perpendicular to each other. That's why we are calling it orthogonal axis. So x and y, if you dot it, it will always give you 0 because they are orthogonal to each other. Okay, so if we want to product it like a dot b, so we say that only ax bx, ay by and az bz will contribute. Other components like ax by won't contribute. So this is the interesting feature of this thing. Now if you have two vectors, like we have already defined it, what is the meaning of two vectors? Like a dot b means that magnitude of a, magnitude of b vector times cos theta. Now if you have these two vectors parallel to each other, means theta is 0. Therefore if I am having x dot y, so I know the magnitude of x, magnitude of unit vector is nothing but 1 and cos 0. Cos 0 is 1. That's why x dot y is your 1. X hat dot y hat. Sorry, x dot x hat, not y hat. Sorry, x dot x hat is going to give you 1. Now, if I am having this x dot y hat, now for this theta is 90 degree. So cos 90 is your 0. So 0 multiplied by anything will give you 0. Therefore, this is the reason. So I knew the result a dot b, but I know now what if you are working in a particular coordinate system, then what could be the component wise solution for this kind of dot product. Now let us introduce cross product. I hope this is visible to you. Okay, now cross product means that I am crossing it. So crossing means ax comma, let us say ax x hat plus ay y hat. Now since we are vector, we are always doing this vector component in this fashion, as you understand here. Bx x hat, by y hat plus bz z hat. Now how can we understand what is the nature of this thing? Now for the cross product, we understand that a cross b is nothing but magnitude of a, magnitude of b and sine theta. Now if I am having these two vectors like x cross x, the same vector, so the magnitude of same vector goes here, but sine of 0 will give you 0. Therefore if you are crossing two vectors which is in the same direction, it will give you the contribution will nothing. If you have two vectors like x cross y, what you're going to do is x then y and their sine 90 degree, because x and y having the angle 90 degree. So this will have some contribution, like x cross y is going to give you 1, or this is the magnitude actually we are talking about. But what is x cross y? Okay, now this is the very important thing, that what is your x cross y. So basically I have already told you yesterday that if you have this product, like one vector is x hat, another vector is y hat. So x cross y means that you are actually rotating x will go into y. So how this rotation happens? As if you are rotating this z vector. So z vector, if you are rotating this way, x will go to y. So x cross y is actually giving you this z hat. Okay, so we have some set of rules. It is called cyclic thing, x, y and z. If you move this way, like x cross y give you z, y cross x is actually, so y cross x is going this direction, so this will give you minus of z. So if you move clockwise, the result will be plus. If you move anti-clockwise, the result will be negative. So y cross z will give you x. Similarly, z cross x will give you y. But if I am going to anti-clockwise, like x cross z is going to give you minus y hat. So if you understand this clock thing, then you can understand that what is this and what is that. So it will nothing but the right hand rule to figure out what is the rotation of two vectors is going to give you. Now to understand that job, like a cross b will be giving you what? If you have this particular kind of structure, that I have these three components and I want to do the crossing of two vectors, then in component wise, what is the result? The result is very much simple. What you have to do, follow the determinant, like you can do by hand also, or by that rule also, or you can do this one. Now write the specific, like here a, so a I am going to write ax, ay, az. Now there is a b, so I am going to write bux, by, bz. So this is we call a matrix form. Now we are going to do the determinant. So to find the determinant, first we will write here this one x hat. So whenever we write this x hat, so this guy, this one and this one, they are blind now. We have to work with this thing. So this will be multiply with this thing and it's going to multiply with this thing. So you have to be specific, like how you multiply. Ay bz minus by az. Now this component, they will again come with negative. So for this part, this will, now blind form will be, let me just erase it to have a clearer understanding. Now if I am choosing this one, so this is blinded. Now we are having this one and this one. Okay. Now what we can do, ax and bz minus az bx. And similarly for z hat, this corresponds, this downside and this side is blinded, and we are having ax by minus ay bx. So this is the component wide result if we do the cross of a cross b, and the vector product will always give you the vector. So because you are seeing that this is the magnitude and we are having x hat magnitude, again we have some specific direction, that's why. Now if you do this, what is the c vector, like what is the magnitude of c vector, we can do a, now magnitude of a, magnitude of b sine theta, or component wise you can do here is that simply a cross b is nothing but square root of this component, like ay bz minus by az, ay bz minus by az square plus ax bz minus bx az square and the other guy, and so on. Okay, so this is the way we can get these results. So this is a very interesting thing to understand, that how this algebra actually take place if you translate everything in coordinate, in a specific coordinate system. So it is done. and I think so. This is the base vector, what we have already done it. Now we are moving to position vector r and displacement.